Something happened in the sky tonight that most people in this country have never seen in their entire lives. And if you step outside, right now you might witness one of the most breathtaking natural events on the face of this earth. The sun just unleashed one of the most powerful solar flares ever recorded in recent history, and the energy from that explosion is heading directly toward our planet right now. Scientists, space agencies, and weather forecasters have all issued urgent alerts warning that tonight, the northern lights could be visible not just in Alaska or Canada, but potentially as far south as Alabama, Florida, Texas, and California. This is not a normal night. To understand what is happening and why it matters so much, you need to understand what a solar flare actually is. The sun is not a calm, steady ball of fire floating quietly in space. It is an incredibly violent, constantly churning magnetic monster that erupts, twists, and explodes on a regular basis. Every few years, the sun reaches what scientists call solar maximum, the peak of its roughly 11-year cycle of magnetic activity. During solar maximum, the surface of the sun becomes covered in sunspots, which are regions of intense magnetic energy that build up pressure until they snap and release that energy outward into space. That release is called a solar flare, and the biggest solar flares, the ones classified as X-class events, are the most powerful explosions in our entire solar system. Scientists describe them using a scale similar to the Richter scale used for earthquakes. Each step up the scale is 10 times more powerful than the last. An X-class flare is 100 times more powerful than a C-class flare. And what just hit Earth recently came from an X 5.1 class eruption, the single most powerful solar flare recorded in 2025 so far, nearly 5 times stronger than the flares that preceded it from the same incredibly active sunspot region. This particular sunspot region, designated AR 4274, had already been causing problems for days before the biggest blast arrived. It fired off an X-class flare on November 9th and another one on November 10th. Each of those flares sent what scientists call a coronal mass ejection hurtling toward Earth. A coronal mass ejection, or CME, is not just radiation or light. It is a physical eruption of billions of tons of charged plasma and magnetic field energy blasted off the surface of the sun and sent racing through space at more than 1 million miles per hour. When that cloud of energy hits Earth, it does not bounce off harmlessly. It slams into our planet's magnetic field and causes a geomagnetic storm that ripples across the entire globe. 2 of those CMEs arrived at Earth on November 11th, 2025, and the reaction was immediate and spectacular. The planetary K-index, which is the scientific scale used to measure the severity of geomagnetic disturbances on a range from 0 to 9, spiked all the way to 8.67. That is just barely below the maximum level. NOAA's Space Weather Prediction Center issued a G4 geomagnetic storm warning, which is classified as severe, the second highest level on their 5-point storm scale. A G5, the highest possible rating, is considered extreme and has only happened a handful of times in recorded history. The result of those 2 CMEs striking Earth simultaneously was something that millions of people across the country will never forget. On the night of November 11th, 2025, the northern lights appeared not over distant frozen tundra, but over cities, farms, and backyards across the continental United States. People in Chicago stepped outside and saw the sky glowing. And residents in Boston looked up and saw curtains of green and pink light rippling across the night. Photographers in Denver captured stunning images from downtown. And most remarkably of all, people as far south as Florida, Texas, and even parts of Mexico looked up into skies that they never expected to turn colors, and they saw the Aurora Borealis blazing overhead. The images that came flooding in from across the country were absolutely stunning. Green, red, pink, and purple curtains of light danced and shifted across the sky like something out of a science fiction movie. In Monroe, Wisconsin, the aurora was so bright and so vivid that it was visible even through light pollution. In Bloomington, Indiana, photographers captured the colors rolling across rural farmland. In Colorado, the lights turned the entire sky over the mountains into something otherworldly. And in Florida, one of the last states anyone would ever associate with the northern lights, long-exposure camera shots revealed delicate purple hues, drifting silently over the Sunshine State. This kind of aurora reach is genuinely rare. The northern lights are normally confined to high-latitude regions near the Arctic Circle. Alaska and northern Canada see them regularly. Residents of Scandinavia, Iceland, and northern Scotland see them during active periods. But for the lights to push all the way down to the Gulf Coast of the United States, the storm has to be extraordinarily powerful. That kind of southward push has only happened a handful of times in the last several decades. The last comparable event that many people remember happened in May 2024, when an extreme G5 geomagnetic storm produced widespread auroras across the country and disrupted satellites, GPS systems, and even precision farming equipment. The November 2025 event may have fallen just short of G5 levels, but it was still one of the strongest geomagnetic storms in years. Scientists from NOAA's Space Weather Prediction Center confirmed that the storm had reached G4 thresholds and explained that two separate CMEs arrived at Earth close together, compounding each other's effects. The service coordinator, Sean Dahl, described the 1-2 punch as hitting Earth with a strong and forceful impact. He said the activity was 8 to 10 times stronger than normal background levels for Earth's magnetic field. That is an enormous amount of energy hitting our planet's protective magnetic bubble all at once. But the storm was not finished yet, because behind those first two CMEs came a third one, the product of the X5.1 flare, the strongest of the entire sequence. That third CME was predicted to arrive Wednesday, November 12th, bringing with it the potential for continued G4 or even G5 storm conditions. NOAA forecasters warned that the northern lights could remain active for 2 to 3 more nights, as the combined solar energy continued to interact with Earth's magnetic field. People who missed the first night of aurora activity still had another chance to look up and witness something extraordinary. The X5.1 flare itself also caused immediate problems when it erupted. The electromagnetic radiation from a solar flare travels at the speed of light, reaching Earth in just 8 minutes. When it arrived, it triggered a wide area blackout of high-frequency radio communications that lasted for approximately 1 hour, disrupting communications across Europe, Africa, and parts of Asia. Radio blackouts during X-class flares are a known risk, and they can affect aviation, maritime operations, emergency communications, and military systems. None of those disruptions during this event caused catastrophic problems, but they served as a clear reminder of how much modern civilization depends on systems that can be affected by space weather. The solar storm also reached up and touched the edge of our space operations directly. Blue Origin was preparing to launch its New Glenn rocket on November 12th, with NASA's Escapade spacecraft bound for Mars. The launch was postponed specifically because of the heightened solar activity. NASA and Blue Origin were concerned about the effects of elevated atmospheric drag and geomagnetic disturbances on the spacecraft during and after launch. The irony was striking and almost poetic. The very solar storm phenomena that New Glenn was trying to escape were the exact same interactions that the Escapade mission was designed to travel all the way to Mars to study. The reason the northern lights exist at all is one of the most beautiful stories in all of natural science. The sun constantly streams charged particles outward into space in what is known as the solar wind. Earth's magnetic field, generated deep within our planet's iron core, acts as a giant shield that deflects most of the solar wind around our planet. But near the poles, the magnetic field lines converge and dip toward the surface, creating openings where some of those particles can slip through and interact with Earth's upper atmosphere. When those charged particles collide with molecules of oxygen and nitrogen in the atmosphere at altitudes between 60 and 200 miles above the surface, the energy from those collisions excites the gas molecules. They absorb that energy and then release it as light, the same basic process that makes a neon sign glow. Different gases at different altitudes produce different colors. Oxygen at higher altitudes produces red and sometimes blue auroras. Oxygen at lower altitudes creates the most common green color. Nitrogen produces pink, purple, and sometimes a deep blue. During extremely strong storms, all of these colors can appear simultaneously, creating the full rainbow display that made the November 2025 event so visually spectacular. During a geomagnetic storm as strong as G4, the invisible boundary where auroras form shifts dramatically southward. Normally, that boundary sits near the Canadian border at latitudes around 65 to 70 degrees. During a G4 storm, it can drop all the way to 45 degrees latitude, which covers states like Montana, Wisconsin, and Maine. During the most intense moments of this storm, it dropped even further, allowing the lights to appear in states far below that line. That is why Florida residents, sitting at roughly 25 to 30 degrees latitude, were able to photograph aurora colors in the sky for one of the very few times in modern recorded history. The scientific community is paying close attention to these events because we are currently living through an unusually active period of solar behavior. Solar cycle 25, the current 11-year cycle of solar activity, was predicted to be a relatively mild cycle when it began. That prediction turned out to be wrong. The cycle has been significantly more active than expected, and NOAA has confirmed that the sun reached solar maximum in October 2024. Even as the cycle begins to gradually decline from that peak, forecasters warn that the most powerful individual flares in any solar cycle often occur during the declining phase, not the peak. That means the dramatic solar weather events of 2025 may not be the end of this story. More powerful storms could still come before solar cycle 25 fully winds down. For anyone hoping to see the northern lights during the remaining active nights of this solar storm, the advice from space weather experts is simple and direct. Find the darkest location you can reach, as far away from city lights as possible. Give your eyes at least 20 minutes to fully adjust to the darkness before deciding the lights are not there. Look toward the northern horizon and watch for subtle movement or shifting color. Even if the aurora is not immediately obvious to your naked eye, point your smartphone camera at the northern sky and take a photo. Modern phone cameras are extraordinarily sensitive to light in ways our eyes are not, and they have revealed aurora colors in skies that appeared completely blank to observers standing right there. The northern lights are not just one of the most beautiful natural phenomena that exist on this planet. They are a reminder that Earth is not floating in a quiet, empty vacuum. Our planet is embedded in a living, breathing, violently active stream of energy pouring outward from the sun every single second of every single day. Most of the time, our magnetic shield protects us from all of it silently and invisibly. But on nights like this, the shield itself lights up and shows its work, painting the sky in colors that no human artist could ever replicate. What makes events like this particularly fascinating to scientists is how much they reveal about the fragility of modern civilization. We have built a world that runs on electricity, satellite navigation, digital communications, and precision timing signals that all travel through space and through the magnetic envelope surrounding Earth. Every one of those systems is vulnerable to what the sun can throw at us. The November 2025 storm caused a 30-minute radio blackout across multiple continents. A storm 10 times stronger, similar to the historic Carrington event of 1859, could knock out power grids across entire nations and take months or years to fully repair. The Carrington event is the benchmark space weather scientists use when discussing worst-case scenarios. In September 1859, a solar flare so powerful it remains unmatched in the modern record struck Earth and sent telegraph systems around the world sparking and catching fire. The aurora was visible near the equator in places like Cuba, Hawaii, and Colombia. If a storm of that magnitude hit Earth today, the U.S. Geological Survey estimates the damage to infrastructure could rival a major natural disaster, with effects rippling across power grids, transportation systems, financial markets, and emergency services all at once. The good news is that agencies like NOAA's Space Weather Prediction Center exist to monitor these events and give advance warning. Modern satellites constantly watch the sun and track CMEs from the moment they leave the solar surface. Scientists can usually predict CME arrivals within a window of 12 to 48 hours, giving grid operators, satellite companies, and aviation authorities time to prepare. The warning system is not perfect, but it is far better than nothing, and the November 2025 storm showed it working exactly as intended. For ordinary people watching the aurora from their backyards and porches and fields, none of the technical warnings mattered in that moment. What mattered was the sky. What mattered was standing outside in the dark and watching something ancient and cosmic paint itself across the night in colors that have no name. What mattered was the feeling of being small and alive on a spinning planet wrapped in a magnetic bubble floating in an ocean of solar fire. That feeling is what the northern lights have always given people lucky enough to see them. Ancient cultures built entire mythologies around the aurora. Norse legends describe the lights as the reflections of the shields of the Valkyries riding across the sky. Indigenous peoples across North America told stories of the lights as spirits of the dead dancing overhead. Scientists today know that the aurora is plasma and magnetism and atmospheric chemistry, but knowing the mechanism does not make the experience less profound. If anything, understanding what you're seeing makes it more astonishing. Tonight, step outside, look up. The universe is putting on a show, and it does not charge admission.